Hi everybody, so far we have done addition, subtraction, and multiplication of whole numbers. Today we're gonna do division of whole numbers. So you can think about what we did earlier with subtraction and also multiplication to extend the concept to the division. So if you think back the multiplication, that's reciprocal of division, right? We thought about multiplication as repeated addition. Similarly, we can think about division as repeated subtraction models. So let's suppose we are subtracting 6 continuously. For example, you subtract from 18, you subtract 6 and you land on 12. Then subtract 6 again and subtract 6 again. So we repeatedly subtracted 6. How many times? 3 times. So if you subtract 6, how many times can we go to land on 0? That is my question. So starting from 18, you can subtract 6 3 times and you land on 0. And my question is, how many times you subtracted 6? The answer should be 3. So starting point, and you're gonna repeatedly subtract until you land on 0. And you're gonna count how many times you subtracted. That is repeated subtraction model. You don't always have to use the number line, right? You can also use concrete models. Using 18 apples, and you take away 6 apples at a time, and you're gonna find out how many times you took 6 apples out. So from 18 apples you take away 6 apples and you have 12 apples. From 12 you take away 6 apples again and you have 6 apples left, and you take away another 6 apples and you have nothing. So you can get to know, so you took it away 3 times. Or you can use this in the real world situation. I like them more because the students can understand that better if they can relate to the situation. So with the same number, 18 divided by 6, you can give a situation like, I have 18 apples and I'm giving away 6 apples per person. How many people can have 6 apples? Right? Then we can give 6 apples to one person and you still have 12 left, and you take away 6 more to give that to next person, and you have left 6 now, and you can give that to the third person. So we can find out, I can give 3 people each 6 apples, right? Okay, so you can model that using the repeated subtraction models. And we can get to know that relationship between addition, subtraction, multiplication, and division. I mentioned this earlier, so let me give you the diagram. So as you can see, addition and subtraction, they are inverse operation to each other, right? So that means if you have something like x plus 3, you can cancel that plus 3 out by subtracting 3 because they are inverse. If you add those two numbers like plus 3 minus 3 together, you get 0. You can cancel them out because they are inverse operations. Similarly, you can use multiplication and division as inverse operations. So you can multiply something, like let's say x by 3. You can cancel that 3 out by dividing that by 3, right? So those two are inverse operation, okay? And we have some relationship between addition and multiplication too. How did we get multiplication? When we had repeated addition, you can change that to multiplication. Similarly, division, you can do repeated subtraction to get division. So you can see some relationship there too, right? Okay. So let me give you another model here. It's called set or partition model. So this is also similar to the example that I gave you with 18 apples to giving that to how many people. You're gonna find it out. But this time you are given 3 people there, and you wanna find out how many cookies can each person get when you had 18 cookies, right? So let's suppose you have 18 cookies and you have 3 kids, Luis, Lorenzo, and Caleb. So you're gonna give each kid the same amount of cookies. So you can give away 1 cookie at a time first, then the second cookies, 3 cookies per person, 4 cookies per person, 5 cookies per person. Then you can have 6 cookies per person. Then you can give away all of those cookies, right? So 18 cookies can be grouped or partitioned as 3 groups, and in each group or in each set, you're gonna have same number of cookies, which is 6 in this case. That is set or partition model. So you are breaking that 18 into equal groups, equal set, or equal parts. Okay? All right. So here is another example. Megan has 120 cookies to put into 24 bags to share with her class for a party. She puts 1 cookie in each bag, dealing them out one by one until they are all gone. How many cookies are in each bag? Pause the video and think about how you can solve it. Okay, so Megan has 120 cookies to put into 24 bags. So we know that Megan has 120 cookies. So let me write down 120 cookies here. If you have 120 cookies and you have 24 students, I think it's a really good situation, so they can relate that. You can always change the numbers here as cookies and the bags as how many students you have, right? So we can make 24 bags by partitioning 120 cookies. So you can make 1 bag, 2 bag, 3 bags, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 bags, right? And I'm gonna give away 120 cookies equally. So I can have 1 cookie, 2, 3, 4, 5, 6, 7, 8, 9. If I give away each person 1 cookie first, I can use 24 of them, right? So I use 24. So you can see how I can relate this partitioning with repeated subtraction. And I have left what? 96, right? 96 cookies. And I can give away the second cookies equally. So each person has now 2 cookies. And right now the process looks like I'm subtracting repeatedly, right? So I can take away, let me actually write it this way because I don't want to run on, because it's not right to use the equal sign like that. So I'm going to do it this way instead. So take away 24 and you got 96, right? And from 96, you're going to give away second 24 cookies. So how much do you have? You have 72 left. And I'm going to give away the third one per person. So everybody has now 3 cookies. It takes some time because I have too many bags. So 3 cookies per person so far. But we still have left. How many are left? 8. Like if you do regrouping, you can do 12 minus 4, which is 8, and 60 minus 20, 48. So you can give away 24 more cookies, 1 per person. So each person now has 4 cookies. 4 cookies. Right? And how many are left in my bag? After giving away 24, I still have 24, right? So I can give the last part here per person. Each person gets actually 5 cookies, and I have no leftover. So we can say that, oh, each person gets 5 cookies equally. Okay, so this model that I just did is taking away repeatedly, right? Taking 24 away, so repeated subtraction. But also you can think about 120 as a partitioning that into 24 groups, 24 parts. And I have how many in each part? 5 per part, right? So I can say 24 parts in each 5 cookies can make 120 cookies. So we can say that how many cookies are in each bag? 5 cookies are in the bag. So you can see how the models are also related, right? Okay, so that is the set partition model. Okay, now let's think about missing factor model. Missing factor model. We already have talked about how multiplication and division are inverse to each other. They are related. And if you think back, the addition and subtraction, they are also related as inverse to each other. And we also talked about fact family, right? So for example, if you are doing 2 plus 3 equals 5, with those three numbers, 2, 3, 5, we can change that to 3 plus 2 equals 5, and 5 minus 2 is equal to 3, or 5 minus 3 equals 2. So we can do the similar things. Using the three numbers, we get to know the relationship there. So if A divided by B is equal to C, that means B times C is equal to A. Well, when we are using only the variables like alphabets, maybe it confuses you. But if you think about the number, actual number, such as 6 divided by 2 equals 3, then maybe it comes faster for you. You can understand that better. So I just used, let me actually write it. So let's think about 6 divided by 2 is equal to 3. And we know the relationship. 6 is equal to 2 times 3, right? We also know that 6 divided by 3 is 2. And we also know 6 is equal to 3 times 2. Or 3 times 2 is equal to 6. By looking at the example that we just did, we can also get to know the relationship too. So what we did here was 120 divided by how many groups? 24. And in each group, we had 5 cookies. How can we check our answer? We can check our answer by multiplying 24 and 5 together to see if we can make that as 120. So let's check. 24 times 5. 4 times 5 is 20. 2 times 5 is 10. Or 20 times 5 is 100, so we have 120. So yes, it is right answer. So we can get to know that the dividing number and the quotient, if you multiply them together, you can get the number that is divided. So the number that is divided, we call that dividend. Dividend. A number that is divising, we call that divisor. And the answer, we call that quotient. If there is anything remaining, we call the remainder, right? So we can have the relationship here. So if you have any number divided by another number and you get that special number C, then we call A as dividend, B as divisor because it's dividing, and this is called a dividend because it's divided, right? C is the quotient. And the relationship here is A can be found by multiplying divisor and the quotient, right? Okay, So we can use that relationship here. So if you think about missing factor model, we can use maybe this example. Maybe it's easier for you to understand what's going on. So Brigitta needs to solve 18 divided by 3. She remembers that 3 times 6 is 18, so the missing factor is 6. In other words, the fact family involves 3, 6, and 18. Since 3 and 18 are used in the problem, the missing factor of 6 is the answer. This model is especially helpful later when students begin learning algebra, and the letter X stands for the missing factor. Does that make sense to you? Okay, so what that means, to find 18 divided by 3 is what? We know the relationship between that divisor and the quotient, right? So if you multiply these two numbers together, divisor times quotient, we know that that will be the dividend. In algebra, what you did is, you know that if you multiply this by 1/3 or divide 3 by 3, you're gonna cancel that out. But when you're multiplying a certain number on the equal sign, only one side of equal sign, that's not equal anymore. So you have to do the exactly same thing on the other side too. So we are multiplying 1/3 on both sides of the equal sign. Then the equality doesn't change, right? But here we can cancel these two out because 1/3 times 3 is 1. 1 times whatever is that whatever, using the identity property, right? And here we can do 18 times 1 over, this is the same as 18 over 1. So 18 times 1 over 1 times 3. 1 times 3. And you can see both are divisible by 3, and you can divide 18 by 3, get 6, and divide that by 3, you get 1. So that is equal to 6 over 1. So you can find what the blank is, what the missing number is, what the missing factor is. To extend that to algebra, we can use this as something like x. So we can solve for x. It's exactly same as I use the blank here. Okay, that's what it means here. Okay. Whole number division algorithm is next what we're gonna do. Okay. So suppose 32 apples were to be divided among 6 kids. Each kid would receive 5 apples, and 2 apples are remaining. So from 32, let's write it down. I think I can just use this model. Okay, so if we use actual, drawing for that to represent this situation, I can draw 32 apples. So we have 5, 10, 15, 20, 25, 32 apples. And there are 6 kids. So we found that each kid can have 5 apples. 1, 2, 3, 4, 5, 6 kids, right? Each kid can have 5 apples, and there are 2 left. So it's called remainder. And what is the quotient? How many apples are there? 5. So 5 is the quotient, right? So what's the relationship between all these numbers? 32, 6, 5, and 2. Here comes the division algorithm. So the number that we divided, we call that dividend. That dividend is equal to, you can multiply how many groups, which was divisor, right? 6 times, what was the quotient? 5. And what's the remainder? You can just add them. How does it work? Take a look at this picture. We need to count 32 as the total. That's the dividend. Dividend, that total number, you can count that as 5 times 6 groups. So 6 groups, and in each group you have 5. So we can count these apples as 5 times 6 because each group has 5 apples equally. But there's remaining apples. You can just add that together, right? So we have 5 times 6 plus 2 many apples. And together, that is 32 apples. So we have 32 apples is equal to 6 groups times in each 5 apples and the remainder plus 2. That is division algorithm. That's the best way to check your division answer, right? So here we can see that the dividend is 32. Divisor is 6. What's the quotient? 5. 5 apples in each person. The remainder is 2, right? So here we have dividend is equal to divisor times quotient plus remainder. The remainder cannot be bigger than your divisor. So in our case, we have 6 as the divisor. If you have more than 6 or equal to 6, you can still give that away, right? So the remainder cannot be bigger than the divisor. Okay, so keep that in mind. That's what it says here. The remainder can be 0, but it cannot exceed the divisor. Okay, so let's take a look at this example. If 123 is divided by a number, we don't know the number, so you need to figure it out, right? But the remainder is 13. What are the possible divisors? Again, pause the video and think about this. So we are given 123. If your number is 123, how's my cursor? Hold on. Okay, so we are dividing 123 by something. So 123 is the dividend, and the divisor we don't know, but the quotient we are not given quotient either. So we are dividing 123 by a divisor, and there's a quotient, but the remainder is 13. That's what is given to us, right? We already know how we can use these numbers. We know the relationship. Thinking about algorithm, division algorithm, 123, the dividend is, when you multiply these two together, divisor and the quotient, and you add the remainder. So divisor times quotient, both are of course whole numbers, and you are adding that by 13, then you get 123. And we need to find out the possible divisors, right? So we need to find out what could this divisor be. That's the question. Okay, now we don't know what the quotient is, we don't know what the divisor is, but we only know the remainder and the dividend. So using the actual numbers, we can do a little bit of algebra. If we subtract 13 from both sides of the equation, it is still equal, right? So we have this gone. So plus 0 is equal to d times q still. How about the left hand side? 123 minus 13 is 110. So we have 110 is equal to d times q. Now what did I say about d and q? Both are the whole numbers, right? They are whole numbers. So think about it. When you multiply two whole numbers, you need to get 110, which means you can think about the factors of 110. So we are going back to the multiplication now. So let me think about prime factorization. Okay, we know 110 is 11 times 10. I just want to go easier number. And 11 is a prime number, 10 is not, so I will continue doing the prime factorization. So I have 11, 2, and 5 as the factors of 110, which means I can rewrite this 110 as 11 times 2 times 5. Or a lot of times we write in order, so 2 times 5 times 11. This is possible because I can use commutative property in multiplication. These are all equal things. Okay, now we know the divisor, the relationship between the divisor and the remainder. What did we say about the divisor and the remainder? the remainder cannot be bigger than the divisor. It has to be less than divisor. And remainder can be 0 but has to be greater than or equal to 0. Right? So knowing this relationship and knowing that R is 13, what do we know about the divisor? Divisor has to be greater than 13. Of course, it should be less than 123 because that's the dividend, right? So we know that is also less than 123. But we also know that the relationship here, d times q is 110. So let me rewrite this again. So we know this, and we also know d times q is 110. And we know that 110 can be decomposed as 2 times 5 times 11. Now, can we make up any d that is greater than 13 but less than 123? Yes, we can. If we pick 2 times 5, that's only 10, which is not greater than 13. 11 is not greater than 13, so that's not a good combination. So if we put 2 times 11 times 5, that's 22 times 5, right? I can say this is my divisor, d, and then d times q is 110. So that's my d, then this is my q, right? So my divisor can be 22. Or I can put 5 times 11 times 2. That's still 110, d times q. And I can say this is d, which is 55. And this 2 is the q, right? So either way, whether I put 22 as d or 55 as d, they are greater than 13 but less than 123. There's no other combination for d that meets this condition. So we can say d can be either 22 or 55. This is not an easy problem to solve. So please re-watch this part again if you don't understand that, okay? Okay, so that is one of the problem. I think you can have that problem in the homework example too. Okay, now let's talk about division by 0 and 1. Division by 0 and 1. So we have a whole bunch of questions here. Let me copy this down to the Jamboard. So let me actually copy this way. Sorry that it will take some time. Okay, let me paste that here. Okay, so we have these questions. Again, I want you to pause this video and solve all of these 7 problems. This is not, easy. It's a little bit confusing. So think about all the, divisions involving with 0. Consider that, okay, before I solve that for you. Once you got them all answers, let's check that with mine. 3 divided by 0. 3 divided by 0. So I want you to think about, you have $3. And you have $3, okay? So $3. And you're partitioning that into what? 0 group. Hey, there's nobody who came and asked for money. There's nobody to give the money. Can we even divide this by nobody? No, we can't, right? So this is called undefined. Later, when you are talking about the rational number, which is a fraction number, we can do something divided by 0. If the denominator is equal to 0, it is undefined. You cannot even have that division. You cannot even have that denominator in the, you cannot have that 0 in the denominator, okay? So whenever you see divided by 0 or over 0 as the denominator, then it is undefined, okay? Now, you have 0 divided by 3. So originally you have $0, you have no money, and your 3 nieces or nephews, they came. So 3 people came and they are asking, can we have some money equally? And how much can each person get? Well, you have no money, so each person gets nothing, right? So it is 0. Here, you have no money, but there's nobody came, so it's still undefined. So whenever you have it divided by 0, it is undefined. So you can see the answer for the next two. Whatever that dividend is, if the divisor is 0, it is undefined. Okay? Now, you have 3 divided by 1. That's same as 3 divided by 1. Which means you have $3 and only one person came and asking, can I have your money equally with nobody? Then how much does this person get? All $3. So 3 over 1 is 3. 0 over 1. 0 divided by 1. You have no dollars. You have nothing. And one person came. How much does that person get? Still $0. Right? So 0 divided by 1 is 0. So you can conclude divided by 1 is always the dividend. And divided by 1 is n. Right? Okay. So we got them all. And let's think about the division algorithm using the base 10 blocks. Perform the division 726 divided by 6. So to represent 726, you need to have flats, 7 flats. So this one flat shows 100 units, right? So you have 100, 200, 300, 400, 500, 600, and 700. 20, you need to have 2 rods, 2 tens, and 6 units. That's what you have. And you're dividing that by 6. So you need to determine how many sets of 6. How many of sets of 6 flats there are in the representation. How many are there? There's one set of 6 flats. So one set, you can use them all, right? All 600 you can use. You cannot have more than that yet because we don't have enough flats to make 6 groups. So we can use all 600, and how many hundreds are left? 100 is left. That's what this one means. And that one means how many groups of 600? One group, right? So we already used this. You don't have to take a look at that. Now, taking a look at this one flat, you cannot do anything for that. So what you're going to do is you're going to regroup one flat into 10 longs because they are exactly the same thing. Now you can give away each longs to the 6 people, right? And you're going to find out how many each person can have. So you can make, here's one group of 6 rods and another group of 6 rods. So each person can have 2 rods, right? So 2 tens are used. Now what is left? We only have these one's units are left. There are 6 of them. So you can take a look at these again, and each person gets 1 of them. So we can have one group of ones. We use them all, right? Using these base 10 blocks, we can continue doing this. So we went up to here, 726 divided by 6. We are taking a look at the flats first. This is opposite from all 3 other operations. Addition, subtraction, multiplication, all of them, we started from the ones places, right? Ones places for the standard algorithm. But for division, you want to start from the left hand side of the place value because we need to regroup them to give away, right? So that's the big difference for the division. So we can see that when you are giving away 6 people equally, how many hundreds can each person have? Each person can have 1 100. So we use 600. This 6 means it's 600. That's why it's right below 700. Now how much is left? 100. But with 100, you cannot give that flat away. So we're going to regroup that as 10 tens. So now we have 12 tens because we originally had 2 tens. That's why we are bringing this down. Now we have 12 tens. Can we give 12 tens to 6 people? Yes, each person gets 2 rods, right? 2 tens. So we use all of those 12 tens, 12 rods. Now what is left? There are 6 units left. Then when you give away 6 units to 6 people, how many can each person have? 1 of them, right? So 6 times 1, you use them all. Now the remainder is 0. So that becomes the quotient and there's no remainder. That is the standard algorithm. Okay. Partial quotients, you can relate this to partial sums or partial products, right? We can also do the partial quotient. I like this one so much too because I can see what's going on in the process. So let's look at this example. A shopkeeper is packaging microwave popcorn bags in cartons that hold 32 bags each. She has 4,224 popcorn bags. How many cartons does she need? So again, pause this video and solve it. Okay, so let's think about this division problem here using partial quotient. So we have 4,000. Let me use green. Okay, I'm gonna use different colors for different type of partial quotient because there's not only one way to do the partial points, but there are several ways, and each of these ways work. And I want to encourage you to use these because it makes so much sense to me, and it kind of represents the repeated subtraction procedure too. So let's take a look. So we are dividing 4,224 popcorn bags by 32 because it says you have a carton, and in one carton you're gonna put 32 bags. So and you're gonna have a second carton and you're gonna put 32 bags of the popcorn. But you have a total 4,224 popcorn bags. So you need to put all of that into cartons and you're gonna find out how many cartons you need, right? So you are doing 4,224 divided by 32 to find out how many of these cartons you have. So we do 4,224 divided by 32. What's the easiest way that you can think about? I have 32 bags. If you have only one, you can use only 32. You don't want to just subtract 32. How about let's go with a bigger value there. If you multiply that by 10, you have 10 cartons, but you only use 320. It's way far away to take away, right? From 4,000 something. So we're gonna go really close to 4,000. So if you multiply 100 instead, you're getting so close, and we use easy number. So 32 times 100 is 3,200. We are getting close to 4,224, right? I'm sorry, it's 3,200. Yeah, we are very close to that. So we use 100 cartons so far. Then how many popcorn bags are left? We have 4, 20, 0, 1,024 carton bags are left, right? So we can use another easy number that is close to this one, 100. We cannot do that because if you use 100 cartons, you're gonna have 3,200 popcorn bags, but you only have 1,000 some popcorn bags. So if we use instead times 10, because I like to use only easy number, like times 10, times 100, things like that. Then we put 320 popcorn bags in 10 cartons. So how much is left? We keep subtracting that until we cannot do anymore. And you have 2 minus 2, 0, 10 minus 300 is 700. Now you have left 704. And we also know that if you have another 10 cartons, you can use 320 bags. And how many popcorn bags are left now? You can regroup this and regroup that to 10 tens. Then you have 10 minus 2 tens, you have 8 tens. 6 minus 300, 300. And we still can use another 10 cartons, right? Because we have 30 times 10 is only 320, which is less than 380. So if we do that, subtract it, then you have 4, 6, and 0. So now we can use this 32 times 1 carton using all 32 bags. So you have 32, subtract it, and you get another 32. So you can have another carton, and you have 0 bags left. So these are number of cartons in these boxes. So if you add all of these together, 100, 10, 20, 32. 132 is the quotient. That's the number of cartons, right? You can also do the similar things a little bit differently. You don't have to break down with the smaller numbers. You can just go 4,224 divided by 32. It's very, very similar to this one. So you know that 32 times 100 is very close to 4,224. And it's easy number, so 3,200. If you subtract 3,200 popcorn bags, now you have left 1,024 popcorn bags. But instead of you doing 32 times 10, you can have 32 times 30, right? Adding these together. So if you do 32 times 30, again, these are number of cartons. And we have how many? 9 and 6, so 960. We use all 960 popcorn bags to put them in 30 cartons. And how many popcorn bags are left? 4 minus 0 is 4, 2 minus 6, you can't, so you need to regroup this, but you don't have enough, so you need to regroup this first. That 1000 can be regrouped as 10, 100. And since this 2 is still smaller than 6, you can regroup 10 as 9, 100, and 10 tens. So you have 12 tens minus 6 tens, which is 6 tens. And you have 9 minus 9, 0. So we are good. And now we know that 32 times 2 cartons will make 64 popcorn bags. If you subtract it, you can have 0. How many cartons did we make? We made 100 plus 30 plus 2. So together, that's 132. Still the same quotient as this one, right? So that's another way. If we continue to do that using different method, I can show you that too. So we can also do it this way. 4,224 divided by 32, right? And you can go the other way around. So you can go 32 times 100. This is similar to the standard algorithm that we know. If we do 30, I cannot have 1,000, right? Then it becomes 30,000, which is way too big. So not this one. Let me go back. Okay, 100 cartons. Then I use 32 times 100. 2 times, 32 times 100 is what? 3,200. Now subtract to see how many there are left. How many popcorns are left? 4,201. 1,024 bags are left, right? Similarly, what we did previously, we can do times 30. 30 times 32 is 960. So if you take that away from the remaining popcorns, you can see there are 9, and we have 9 here, 10, 12 minus 6, 6, 9 minus 9, 0. So 64 popcorns left. Now we can have 2 cartons to make 64. Subtract, and there's no remainder. So we know that there are this many cartons. We put 32 popcorns in each. So that's 132, right? So all of this work, and you can choose, and you can also relate this to the standard division using long division here. So let's continue doing that. So what we do is we're gonna see how many 32 goes in from the beginning. In 4, no, it doesn't go in. So we are looking at the next 2 digits. Yes, 100 goes into 4200. 32 times this is 100th place. 100 will be 3200. Very similar, right? And how many popcorn bags are left? You can do the subtraction, and you have 1024. And here you're gonna only look at from the left hand side of the digit. So in 1000, well, 1 is less than 32, so you cannot put 32 in there. 10, no, you can't. So 102, even if it's 102 tens, you can take a look at 102 tens. And how many 32 goes in 102 tens? So we can say 3 tens, because 3 times 2 is 6, and 3 times 3 is 9. It's small enough to subtract from 102, and the remainder only up to this digit, it should be less than 32. So if you subtract that, what do we get? 102 minus 9 is 6. You can regroup this as 9 and 12. So 6, yeah, 6 is less than 32, so that's good. And then you can drop this down as 4. Because this was not 96, but it was 960 actually, right? So 32 times 1 makes 64, times 2 does. Because that's 64. Subtract 64 from 64, 0 is remainder. So we can find 132 using the long division. That's a standard algorithm. And these are the partial quotient. Personally, I like this one so much more because I think it's really linking with my thinking process about repeated subtraction. I don't know about you, but you need to know all of these different methods there, okay? The strategies. Okay, here is another example that you can do. Sorry for the blurry wording, I just copied and pasted and it happened. But we can read it. There are 3 seats in each row of an airplane for passengers. If there are 63 people boarding the airplane, so the total number is 63 people. And there are 3 seats in each row. Okay, it's very small plane, I think. How many rows of seats are needed for the passengers? So what can we do? We can just divide 63 by 3. And I will let you finish that, right? There should be several methods that you can use. Maybe you can just take away 3 each time and see how many rows I need. 3, 3, 3, 3. Right? You can do that, or you can just go with the missing factor. So 3 times 1 makes 63. You can find 21. So you can say that there should be 21 rows. 3 in each, so 3 times 21 is 63. That's another way. You can also do 63 divided by 3. You can use the long division, or you can use the partial quotient. Okay, so let's do that. Okay, here we go. And the mental computation and estimation. So in order to do the mental computation of the division, we can also think about different strategies. One is breaking up the dividend. We talked a lot about the breaking up numbers, right? So we are decomposing the numbers. So if you are breaking up the dividend into two parts, like two digits and two digits together, because when we have single number multiplication, you always get two digits. For example, 7 times 6 is easier than 7 times what makes it this whole thing, right? So we see that 42 is actually 4,200, 4,200. So 7 times what makes 4,200? 7 times 600 does. So on this left hand side, you can have 600 as the quotient, but we still have 56. 7 times 1 makes 56. 7 times 8 does. So by breaking up, by decomposing 4,256 into 4,256, we can find the partial quotient here, 608, right? So the actual quotient together of this partial quotient should be 608. Doesn't that make so much sense? I think it does. Okay, so next problem is 100, 105. It's a little bit quieter now. My fan was running so hard, so I had to stop the video. But anyways, we're gonna use the comparable numbers, okay, to divide 105 divided by 3 and 232 divided by 8. Let's consider these two problems, both using comparable numbers. Comparable numbers means you're gonna use easy number that you can deal with. Okay, so if I think about divided by 3, I know that 3 times 30 is 90, so I can change this into 90 and 15, because 90 plus 15 is 105, and I like 90 and 15 to divide it by 3 rather than 105. They are easier numbers, but nothing has changed because 90 plus 15 is 105, right? So I'm gonna just look at these by breaking the dividend into two parts like this. 3 times 1 makes 90. I know that 30 makes 90. So 3 times 30 is 90, right? Yeah. And 3 times 1 makes 15. 3 times 5 makes 15. So I have no remainder. And the quotient is 30 plus 4. So I can say that is 35. Right? How about this one? 232 divided by 8. What's the comparable number for this kind of division? We know that 8 times what is close to 234? 8 times 30? Because that's 240. Oh, it is very close, right? So if I need a little bit more space, so I'm gonna move this here. Can I write 232 as 240 minus 8? Very similar to this addition here. Nothing has changed here. 232 is still same as 240 minus 8. And I'm going to divide that by 8. And I'm going to look at the partial quotient there. 8 times 30 is 240. Right? And we also know 8 times 1 is 8. 8 times 1 is 8. But what operation do? We do subtraction. So it's exactly the same thing. If you subtract those things, it's 0. You are taking away exactly same amount, 240 minus 8, from 240 minus 8. So the remainder is 0. What's your quotient? Your quotient is 30 minus 1, which is 29. This is so much easier than you do the long division, isn't it? So if you do the long division for this one, it's gonna be like 8 times what is close to 232. I know that 3 is too big, so I'm gonna go with 2. And 2 times 8 is 16. Subtract, and you have regrouping going on here. 13 minus 6 is 7. 8 times what is 72? 8 times 9 is 72. If you don't remember this, you need to keep adding 8 until you get to 72, right? So it takes some time, but this one, I think it makes so much sense. What do you think? Do you agree? I hope you do. Okay, so that's mental math. And we're gonna talk about estimation. Estimation is approximating the number, right? So computational estimation may help determine whether an answer is reasonable. So by estimating, you can say that, oh, it is reasonable answer when you're checking your own answer. So let's think about this estimation. 4,163 divided by 4. 4,164 is close enough to change that to 4,000, so we can have 800 as the quotient. Now I'll need to think about this. Will your actual quotient larger than 800 or smaller than 800? Take a couple seconds and think about it. You change the number, dividend smaller number. So for example, when you have 4,163 apples and giving that to 5 people, will each person get more than when you have 4,000 apples and dividing that by 5 people? Of course, when you have more apples and giving away to exactly the same number, your quotient should be bigger. Each person gets more, right? But since you underestimated, your quotient, actual quotient, has to be larger than 800. So if your answer, after you do the long division for 4,163 divided by 5, and your quotient is smaller than 800, something went wrong. You need to redo that, right? So you can use the estimation to see your answer is actually reasonable or not. Okay? Okay, try this too. Estimate the following mentally and explain the answer. Again, please pause the video whenever you are given the problem and then continue to watch after you solve your own problem. Okay, flyers are to be delivered to 3,625 houses. 3,625 houses. And there are 42 people who will be doing that distribution. If distributed equally among 42 people, approximately how many houses will each person visit? So we are gonna just estimate it instead of using actual value here. So let me use Jamboard to have, hold on, what was the number? I already forgot. 3,625 by 42. Okay, so there are 3,625 houses and the delivery man number is 42. So we're gonna divide the 3,625 by 42. But we just need to estimate it, right? So how would you change this number? 3,600 is very close to 3,600 and 42 is very close to 40, and these two numbers are comparable, right? So I think that's good. And because you are rounding down on this number and you're rounding down on this number, and then it should be good, right? So 3,600 divided by 40, you can think about 40 times 9. 40 times 9 is 360, right? So you have 90, which means among 40 people, each person can have about 90 newspapers to deliver, or about 90 houses each person can visit, right? So we can do that. And the last think in this section, okay, yeah, it is. Last section is order of operation. You already know PEMDAS, right? That's a good way to remember. But when you're remembering PEMDAS, you have to be very, very, very careful, because in PEMDAS, MD and AS, you need to think about, this is not an order. Multiplication doesn't come before division. Whichever comes first, you need to do that operation. If division comes before multiplication, you have to do that first. So it comes from left to right. Same for addition and subtraction. Addition doesn't come always before subtraction. Whichever comes first, you need to do that operation. Okay, so we're gonna do one example here. 6 times 4 divided by 12 plus 72 divided by a minus 9. Let me copy down that expression here. So what we have is 6 times 4 divided by 12 plus 72 divided by 8 minus 9. I don't see any parentheses, so we are good. Now, we need to look at the exponent. I don't see any, so we are good. Now, multiplication or division, I'm going to write them side by side. So whichever comes first, you have to do that. So let's see. Oh, I see multiplication, division, and division here. What comes first? This comes first. So you're going to do this operation first. 6 times 4, 24. Then you can rewrite the rest of that, right? And we are not done with M and D, so we need to do this one because this division comes before this division. 24 divided by 12 is 2. So that is the same as 2 plus 72 minus 8 minus 9. We are not done with the MD, right? We still have the division. So you're going to do this one before you add 2 by 72. You shouldn't add these two first, okay? So 2 plus, you're going to do this operation. 72 minus 8, 9 minus 9. Now, you can add these two together because addition and thus AS. Whichever comes first, you can do that. In this case, addition comes before subtraction. So you need to do the addition. 2 plus 9 is 11. 11 minus 9 is 2. Let's have one more example. I will just make it up. Something like 2 times 3 squared minus 5 divided by 2 plus 5 times 3. If you are given problem like that, let's continue with the PEMDAS again. When you're writing, put M or D slash and AS as well. So parentheses, yes, this time we have the parentheses. So we're gonna do this parentheses first. In the parentheses, we have square minus 5, which is exponent, comes before subtraction, right? So in the parentheses, you can do 9 minus 5. So let me just rewrite everything. Divided by 2 plus 5 times 3 is equal to. Now we are not still done with the parentheses, right? So we're gonna do 4 in it, divided by 2 plus 5 times 3. Now we have just number in the parentheses, so you can just disregard this parentheses. Now we have multiplication, division, multiplication and addition and multiplication. So in order, whatever comes first, from left to right. So from left first, 2 times 4 is 8 divided by 2 plus 5 times 3. We still have the division and multiplication, so let's do division first because it comes before multiplication. 8 divided by 2, 4 plus, now you can do multiplication, 3 times 5, 5 times 3, 15. Now it's just addition, so it's going to be 19. Okay, hope that was helpful. And that's it for section 5. And next one is chapter review. You don't have to do that. For chapter review, you have a chapter review homework, right? So that's kind of lengthy. If you have any question, please don't hesitate to contact me. But I want you to try your best to solve all the problems. Okay, and don't wait until the last minute because it's very long and you may encounter any difficulties to solve the problems. So good luck with that, and then you're gonna have the test coming up. All right, good job guys, see you later.